going to see an MLOps CLI in action. The goal here is assuming that you have data science Python scripts and a YAML config, the CLI will help you convert them into an executable ML pipeline. So in the screen you can see here that as a data scientist I have created some of the steps, for example data preparation, evaluate, train. MLOps CLI is actually a virtual environment where I'm going to run the commands basically. So inside each of the folder you have a Python script. It's just dummy script, and the requirement .txt, which is basically the dependencies needed to run that individual script. Then we have a job order. This is where we have defined that okay, what is the pipeline name, what are the steps involved, where is the requirements or the dependencies file available, where is the Python script available, and if there is dependency on the previous step or any other step, that also can be defined here. Now let's see, assuming that I have a Python script and this job order, how the CLI can help orchestrate the pipeline in action. So I'll first do pip show MLOps CLI just to see if there is already package installed. It is not installed, so I'll just do. Yep. So that should install this package. Now what I will do, I'll just go to this command line and we will just try out each command one by one. So first is the dry run command. The idea here is it will just validate whether the job order YAML that is being supplied, whether it is valid or not. So it will do some sort of validations. For example, it will see whether the dependencies mentioned are valid or not. For example, if it is mentioned that data train depends on data prep, so whether data prep is a valid step or not, or whether the requirements.txt is having a valid path, or this Python script is having a valid path or not. So in this case, we can see that okay, the job order looks fine. So I'll go ahead and try to execute. So I'll come back here and I'll now execute. If you notice that this execute takes the job parameter and the job config, which is again the job order YAML, and it also takes observe parameter, which is an optional. If passed, it will try to calculate some of the resource consumptions like CPU and memory usage for each of the steps. So let's see what happens now. So you can see here that okay, a few things are now started to run, and we all at the same time, if you notice, some additional folders have started to come up. So for example, there is this MLOps artifact. Essentially, this is the folder where all the runs will be, the data of all the runs will be stored. A virtual environment folder is also created for each, where because we are creating the virtual environment for each of the steps. And if you see the logs, we are basically installing the dependencies as defined in the requirements.txt. Once that is done, we are basically running the Python script. Likewise, you have a train. So it went to train step. So here the virtual environment is getting created, and then after installation of the packages, essentially the train script will run. Meanwhile, under MLOps artifact, you can see that there is a tag which is basically generated and saved. This is what we had given in the job order YAML, where we have told that okay, data prep step will come first, then train, and then evaluate. So it seems it has run, and you can see that since we passed as a parameter, it is calculating some of the things like how much time it took, what is the peak memory usage, average CPU usage, etc. Now let's try to run it again and see what happens. So if you see here, the interesting thing this time is that it is using cached environment. So this is another thing that is basically available. So the environments are already created. It will not go ahead and create the environments again. It will just reuse and share the results. Now once the execution is done, you can clean up the steps. So I can come here, I can do, let's say if I want to clean up the environment for train, I can just execute this cleanup command, step name is train. It will basically delete that train environment only. So from here, if you see, the train environment is basically gone. At the same time, if I just do all, it will basically clean up all the environments. So nothing is available now. Okay, so apart from this, you can do one more thing. So for example, so to visualize, all the things that are being done. We have a dashboard also available. So this is basically a similar application, which is pointing to the output artifact directory, and then basically it tries to give you some view about how the run happened, what is the pipeline name, when it was started, each step, how much time it took, and all that, and the tag as well, and all the runs will be essentially captured here. Now this is again on the file system, so it's like that. But eventually, it can be plugged into a database with a served by an API, and it can be extended further. So this concludes the demo on MLOps CLI. There will be few improvements that we will be coming up in future. But the point here is, so in this demo, what we did is, assuming that we have some Python scripts, we define the job order and let the CLI take care of creating the pipeline, executing them. Another thing I want to highlight here is if there are jobs which are in the same level in the tag, right? So if I were to go here, I'll just choose a dashboard here in this case. So if there was, let's say, two data preps pointing to train, the two data preps will run in parallel. So that parallelization is also handled internally within the CLI. So all the major lifting part, I would say, is basically with the CLI to handle and to execute. So yeah, thank you.